Today's AP review is number 9, and for AB, this is the last AP review packet. For BC, there's a little bit more left to do. For AB, well, this packet's topics, there's kind of two. The first one is practicing with multiple choice questions. All of the problems that are in this packet are intended to be done without the use of a calculator. And for the multiple choice. Then there's some free response practice, which has to do with related rates. And the first, second, and fourth questions included in this packet are calculator, and the third one is supposed to be no calculator. So let's get started on the multiple choice practice. I'm going to do 2 multiple choice and 1 free response with you, and then you are going to be able to do the rest on your own or in your groups. So for the first one, we're taking the derivative of y equals the quantity 4x squared plus 5 all raised to the 3rd power. In order to take this derivative, we're going to have to use the chain rule. So that means we are going to take the derivative of the outside function, so y prime will equal 3, because the power comes in front, copy the inside function, subtract 1 from the power, so that goes down to a 2, and then multiply by the derivative of the inside function. The derivative of that inside function would be 8x plus 0, which we don't need. So we can multiply the 3 times the 8x to give us 24x times 4x squared plus 5 quantity squared, which would be answer choice D. So that is just your basic chain rule derivative multiple choice question. Okay, for this problem, we're evaluating a definite integral from 0 to 3 of 1/3 e to the negative x over 3 power dx. So this is a definite integral with a u substitution. The inside function here, u, is going to be negative x divided by 3. Or I could think of u as being negative 1/3 x. The derivative of u with respect to x is just going to be negative 1/3. So du equals negative 1/3 dx. I have a 1/3 in the problem already, but I do not have. So we're going to multiply by negative 1 on both sides. Negative 1 du equals 1/3 dx. So now I'm going to do my u substitution. Oh wait, no, not yet, because it's a definite integral. I need to evaluate u of 0 and u of 3. So what I'm doing here is I'm substituting my limits into my u to adjust the limits, because this is a definite integral. So it's going to be negative 1/3 times 0, which is 0, and negative 1/3 times 3, which is negative 1. Notice that my lower limit stayed the same, but my upper limit is now lower than my lower limit. So we will have to make an adjustment for that. So we are now going to rewrite this with our u substitution. The integral from lower limit was 0 is still 0. Upper limit was 3 is now negative 1. And now I have e to the u power. 1/3 dx is coming out, and negative 1 du is going in its place. So I'm going to flip-flop my limits. So I'm going to put the little one on bottom and the big one on top and put a negative out in front. And now the negative 1 can come out in front of the integral, which multiplies by the negative already there to create a positive 1. So my negatives are both gone. So I have the integral from negative 1 to 0 of e to the u du. The integral of e to the u is just e to the u, and we're going to evaluate that from negative 1 to 0. So now I plug in my upper limit, subtract what I get when I plug in my lower limit. So this is 1 minus e to the negative 1. And I find that answer as option E. Okay, so now we're going to do this first related rates problem together. It says a 12,000 liter tank of water is filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by R of t, measured in liters per hour, where R is given by the piecewise defined function. R of t equals 600t divided by t plus 3 for 0 less than or equal to t less than or equal to 5, and 1000 e to the negative 2/10 t for t values greater than 5. So part A says, is R continuous at t equals 5? Show the work that leads to your answer. So we talked about continuity in our last packet. So we know that continuity is a 3-part definition. The first part for continuity is we have to make sure that R of 5 is defined. And so that would be using the top piece of our piecewise function. So 600 times 5 divided by 5 plus 3. So 600 times 5 is 3,000 over 8. And this is a calculator problem, so you can use your calculator to simplify that if needed. 375 is what R of 5 equals. Now we have to make sure that the limit exists. So the way that we've determined if the limit exists is if the limit as t approaches 5 from the left is equal to the limit as t approaches 5 from the right. So the limit as t approaches 5 from the left is going to be the same thing as the limit as t approaches 5 from the left of the left-hand piece of this piecewise function, which is 600t over t plus 3, which we just determined would be 375, the same thing as R of 5. Now we need to do the limit as t approaches 5 from the right, which is going to be the same thing as the limit as t approaches 5 from the right side of 1000 e to the negative 0.2 t. This is the function that we use for all values greater than 5, so that would be on the right side of 5. So I'm going to use my calculator to do this. 1000 times e to the power of negative 0.2 times 5. So I'm just doing a direct substitution. This is 367.879. So my left-hand limit and my right-hand limit are not the same. So that means the limit does not exist. So the limit as t approaches 5 of this function R of t does not exist. Therefore, R of t is not continuous at, that was supposed to look like the at symbol, t equals 5. Okay, so let's go on to part B. So find the average rate at which water is draining from the tank between t equals 0 and t equals 8 hours. So this we're going to use the average value formula for. 1 divided by, this is going to be a and this is going to be b. So a is 0, b is 8. So 8 minus 0 times the integral from 0 to 8 of R of t dt. Now in order to do this, we're going to have to break it into two integrals, dividing it at 5, since our piecewise function splits at 5. So it's going to be 1/8 times the integral from 0 to 5 of 600 t over t plus 3 dt plus the integral from 5 to 8 of 1000 e to the negative 0.2 t. And you can enter that in your calculator to get see this first part, and I'm distributing the 1/8 when I enter this in the calculator. It's 154.313, and I'm going to keep all the decimal places. I'm going to store that as alpha A, and I'm going to add that, and then I'm going to put in my other integral. Clear out the old integrand. Five to 8 are my limits. So this one gives me 103.739, and then if I add that to the one that I stored as alpha A, I get 258.053. So this part, oh, and I forgot to mention on the last part, it was worth 2 points for saying that it was not continuous with your complete analysis included, which needed to show that the left-hand and right-hand limits were not the same. For part B, this is worth 3 points. 1 point for the integrand, which could be r of t, or it could be split into 2 parts. 1 point for your limits being correct and your constant 1/8, and 1 point for your answer, so 3 points total. All right, now we're going on to part C. So on part C it says find r prime of 3 using correct units, explain the meaning of what that value is in the context of this problem. So r prime of 3, I'm just going to take the derivative in my calculator of the first function, because that's the one where 3 is included. So in the calculator, I am going to type alpha window, option 3 for derivative, d dx, then type in alpha y equals option 1 for numerator over denominator fraction, 600x over x plus 3, such that x equals 3. And that gives me 50.000. So that is 1 point for having that answer. Then we're supposed to explain the meaning for another point. The rate at which the water is draining out of the tank at time t equals 3 hours is increasing at 50 liters per hour squared. So the rate that water drains out at t equals 3 hours is increasing at 50 liters per hour squared. All right, part D, the last part. Write but do not solve an equation involving an integral to find the time A when the amount of water in the tank is 900 liters. So This is to actually find the amount of water. So to write the amount of water, since this is a R of t is measured in liters per hour, if I find the integral, that will multiply the independent and dependent variables, resulting in just liters. So I want to integrate from time 0 to the ending time a, which is going to remain a variable, of R of t dt, but I'm going to have to add on the initial amount of water. So at time 0, the tank is filled to capacity and it has 1,200 liters. So this will be 1,200 plus the integral. So this asks us to write but not solve an equation. So an equations must have an equals involving the integral, which we have, to find the time a when the amount of water in the tank is equal to 9,000 liters. So we need to put in equals 9,000 to finish out this equation. So for this part D, you get 1 point for your integral. That would include the limits and the integrand. And 1 point for the equation, which would need to have all of this. It could be anything algebraically equivalent to this equation. So say, for example, if you isolated the integral by subtracting 12,000 from both sides, that would also be acceptable. Anything algebraically equivalent is accepted, but this is probably most likely the way you would leave it. Okay, so you're now ready to finish off this packet for homework. Keep in mind all the multiple choices, no calculator, and for the free response, they are all calculator except for the third question, which is the one that has the table labeled number 5. It doesn't say no calculator, but that one is a no calculator problem. All right, good luck. Have fun. Bye-bye.